Hi, my name is Jim Moyle and I am a Windows Virtual Desktop GBB working for Microsoft. I hope you're having a great day today at Digital Disrupt. And we're here today to talk about deployment automation and in most particularly image management. You can find me on Twitter at Jim Moyle and my YouTube channel at youtube.com/Jim Moyle. So, as I say, we're supposed to be talking about image management today. Now, many of you may be asking, why do I need image management? Well, we need to make sure that users have both a secure and a totally consistent environment. And that consistent environment should be the same across all environments, whether it's a disconnected laptop, whether it's a desktop, whether it's a VM in your data center, whether it's an application delivered from the cloud, they should all look and feel the same. We definitely need to make sure that things are secure. So both the OS and the applications need to be patched. And we need to make sure that application versions, which applications we're using for different jobs, are consistent across all those environments we just spoke about before. It also needs to be agile. So organizations need to be able to both upgrade applications to add new features and to add or replace new applications when needed. And all of this needs to happen in a short amount of time during maintenance windows and needs to be perfect. So when we talk about image management, there's a massive difference between pooled and personal. Now, personal should almost always be managed the same way as you're managing physical desktops on-prem. Now then, there are some exceptions to this. You may not have any physical desktops on-prem. Or you may be trialing out a new way of doing things in the cloud for personal desktops. But eventually they should be the same. And I think that probably where you should be aiming for, given the current technology stack at the moment, is probably Windows Update for Business managed by Intune for the compliance and update of those VMs, and maybe System Center for the deployment. But that's by the by. What I really want to talk to is pooled. Now then, if we look at Windows Virtual Desktop, the pooled workload is more than 90% of the use case that we see currently in Windows Virtual Desktop. Probably because you can gain such large advantages if you do it right. You can update once in your master image and roll out. You can roll back. If you have a problem, you can instantly roll back. You can reset to your known good. And every VM is the same. So you shouldn't ever have to do any troubleshooting. If you've got a VM that for whatever reason becomes out of sync with its with the others in its host pool, that's fine. You just blow it away and recreate it. You never have to investigate that VM. The troubleshooting should all happen before that master image is deployed. And even if you do have problems, as we say, you can always roll back. So if you've got a master image for your pooled desktops, how often do you update that? Well, if we take that top example, so that's the pooled master image, that's updated probably once every 1 to 3 months, if you have a reliable process. Now, a reliable process, although I would love if it was automation, doesn't actually have to be automation. It could be a checklist. That's absolutely possible to make reliable. It's very difficult to make reliable, but it's definitely possible. If you don't have a reliable process, then you tend to find that people start doing only security patches. And those security patches, because they're the only thing that are being deployed, your environment stays very static. And that means that agility for the company that I was talking about previously just doesn't really exist. Very bad if you're not able to update your images. Some customers, the exact opposite of that. Super automated. They've got data which lives in applications, and those applications are installed in their image. I've seen everything from mapping to medical to media applications have this sort of architecture. So that means that they'll update their image every single time that application is updated. ISVs who are providing remote applications will often do this. So it may be that you've got an application and an image that's updated daily or weekly. So very, very different use cases in terms of how you update. What are the real customer asks here? And we'll see a bit of variation in this. I work for Microsoft, and generally because of that, people want an integrated stack. Yeah, they want one tool for everything. They say, well, just because it's Windows 10 offline on a laptop or Windows 10 multi-session living in Azure providing a remote app, I want a single tool to manage Windows 10. I can understand that. It reduces your reliance on different skill sets. They also say, I want it to be a Microsoft stack as much as possible. Fair enough. Now, we have a lot of great partners. So from Citrix and VMware who have got great offerings around the control panel, to a whole host of WVD ready partners that you can find on our documentation. So we don't ever say that we do it all. And we don't want to do it all, right? That's why we have partners. So if we take this last point here, so this is the opposite to the top point. And I see this in customers as well. They say, well, I want a cloud service. I've got a whole lot of legacy stuff on-prem that's spaghetti, that's difficult to maintain, it's difficult to run. I want a bit of a clean slate. So I want to do as much as possible 100% cloud. I want that cloud service to be properly cloud. I don't want to be extending my on-prem tooling into Azure. So it really depends on the customer, the variation between that top and the bottom one as to what they want. All right. So how many images do you want? Well, everybody always says one. Well, there could be many master images, languages, regions, departmentals, OS, application silos, life cycles. All of these need to be accounted for. And if we only take 3 languages, 5 regions, 4 departments, and 3 life cycles, well, it's no coincidence I've got a photo of a dartboard there, because that's 180 different master images. Now, you might not consider them different master images, right? If it's just the same image replicated to different regions. But it's still something that you've got to do, you've got to manage, you've got to think about in terms of those master images. So first off, let's have a look at the manual build or the checklist build. So it can be very fast to implement, and of course, and I'm not going to go on about the pandemic, but it was urgent that people got their remote working environments up and running, and so this manual build or checklist build was used a lot. That does incur technical debt. You're gonna have to come back around and automate that or fix it or make sure it's repeatable. There is technical debt there. And that debt is what was listed in the cons ahead of us, right? It's error prone, and it's difficult to repeat. Somebody makes a change, somebody troubleshoots an image, somebody upgrades something. You can have regression bugs, you can have all kinds of stuff with a checklist build. If you do want to get away from a checklist build and do some automation, there's a whole host of tooling available to you. From the Azure Update Management, SCCM, or it's now called Microsoft Endpoint Configuration Manager, Intune, a whole lot of ARM scripts and ARM templates. Azure Image Builder, we'll dig into Azure Image Builder a lot in the upcoming slides, and the MDT and third parties as well. Just to show you that Endpoint Configuration Manager now has a policy enablement for multi-session OS, so it works with Windows 10 multi-session. But I really want to show you a solution that we built for some customers. Now, some of this stuff isn't what we built for the customer because it's their IP, and I don't want to make that identifiable. But we'll take you through what they wanted. They wanted some triggers to start with. They wanted to start this whole chain. Now, they wanted a couple of triggers, but one of them was a web front end so that an admin could go in and say, I want this. And then they wanted the image creating. Then they wanted that image replicating to a whole load of Azure regions. And inside those regions, they wanted the VMs stood up in the host pool. And effectively at that point, you're cutting across your canary users and you're testing your new image, and you're testing it all around the world with your different languages, etc. So the actual tools that we used are here. So like I said, there was multiple triggers. We got the web form for the manual initiation. Schedule, so once a month they also wanted the image to be created. So after a new gallery image is created, they wanted to be based on that because that has all of the patches in it. And also, just in case they've got a line of business app that they needed to create a new image from, if that application updated as well. So all these triggers are created with Azure Logic Apps. That Logic App then kicks off an Azure function. That Azure function then runs Azure Image Builder. While that's building the image, it's talking to Azure Files. It's talking to MDT. Now, MDT looks odd in there, but we'll talk about why that is in a second. Key Vault for secrets and credit creds. Then it chucks into Azure Shared Image Gallery. Shared Image Gallery is super interesting because what that will do for you is take over the entire replication and versioning of your images without any effort in your pod. From the Shared Image Gallery, we're then talking another Azure function, which is going to talk to Windows Virtual Desktop, create the host pools, populate the VMs, stand everything up ready for the users to log on to. Now then, if you're not familiar with Azure Image Builder, it's got 3 stages, right? The source, where you're building the actual OS itself, that's used, it uses Packer to do that. So if you're familiar with Terraform, that also uses Packer. In fact, you can actually use your Packer customization scripts in Azure Image Builder. Talking of customization, that's the next stage. So at that stage, you'll take in all of your applications, you'll take in all of your optimizations, and then once all that's done, you're distributing it to the Shared Image Gallery, and that's going to chuck it out to all the VMs. Azure Image Builder is currently in public preview. It's going to be GA super soon. Look out for that. Those are the regions it's currently in preview. That doesn't mean that you can't use it across the globe. You absolutely can, but those are the service regions. If you've used Azure before, you'll recognize that what we've got on the left is a lovely JSON template. You submit that to the image builder, and that will build your image from, for our case, a gallery image. So that's Windows 10. Let's say we're picking Windows 10 multi-session with Office 365 Pro Plus. All right, and we've just gone out and picked the 2004 version because that's out now. We're looking and we're creating all the applications in that customization step, and then we're distributing out to the third of those 3 picks, which is the Shared Image Gallery. Let's dig into that customization step. So the customer had an existing deep investment in MDT. They use that on-prem for automating all of their image builds. Now, there is a customization framework within Azure Image Builder itself. It's fairly basic at the moment. And the customer didn't want to rewrite their MDT task sequences in PowerShell. You could also use something like Chocolatey if you wanted something a bit more cloudy and a bit more cool than MDT. But if you've got an existing investment, MDT is what we used here. Now, we see that top red box, Run Evergreen. Evergreen is a community PowerShell module created by a good friend of mine, Aaron Parker, which will go out and it will grab all of the most common applications for your Windows Virtual Desktop, and it will grab the latest versions of those, grab the URL, and allow you to install the latest versions of your applications. You can install whatever version you like, but I like installing the latest versions. Languages. So we've already got the ISOs in Azure. We're just going to map a network drive to those. Then we're going to install the languages on demand. Also with the optional features for those languages. And then the applications themselves, right? We know the URLs. We'll download the latest binaries. We'll install them. So Evergreen has got all kinds of stuff in there, including the FS Logics agents, Office 365 if it wasn't already part of the gallery image, etc., etc. All right. Now you've got your image, you've had it customized, and you're using Shared Image Gallery to replicate it around the world. And just a little demo here. So let's just create a host pool. However many VMs we want, 10 in this case. Let's tell it our subscription ID so that we know where to put those VMs. Shared Image Gallery name. Now what's interesting here, right, is you're sending parameters to, that's the customizer, right? This is the region for Shared Image Gallery. The host pool is for Windows Virtual Desktop. So we're picking out the unique parameters that we need for each service as a whole. So now we've filled out the form. What happens is that we've got a logic app. We can see that that logic app has been triggered by a new response. And that response ID is 19. All right, so let's go stick 19 in a variable. And we'll get those response details. So we'll go and ask Windows Forms for those outputs. And we can see we've got the submission time, we've got all those details that we put into the form. Now the logic app is going to start the Azure function. It's going to run the PowerShell to run Azure Image Builder. That JSON that we see inside the invoke AIB step of the logic app is going to form the parameters to run the function for the image build. Excellent. Now, we don't have to start it with that web image, right? We could recur every 1 month. Yeah. And how do we do that? If we need multiple triggers, well, we can use a service bus and we can send a message across that service bus. And we can start the same chain of events by whatever trigger we like. And logic apps have, honestly, thousands of triggers, thousands of different ways that you can start off this chain. So that's what the parameters look like. Exactly the same as what we took, and we're just splatting those to that deploy to the AIB settings. And if we have a look at invoke AIB, we can stream the logs, and that Azure function is running serverless in the background, starting Azure Image Builder, and that same. All of those same logs are actually in log analytics as well. So however you want to look at those logs, that's absolutely possible. Now then, what we're doing here. So we're going to see in a second that we're going to get a brand new resource group. And there we are, see the new resource group for the demo. And inside that, we've got a shared image gallery. So it created one for us because we didn't have one already. And now let's have a look at this staging group. Now this staging group is one that's created automatically by Image Builder and inside the storage account. And let's have this let's download the customization log. It's going to take a couple of seconds while I verify my subscription and all those details. But the customization log, if you're familiar with Packer, you'll be familiar with this file name, showing you that it is just Packer underneath. And once we open the Packer log, we'll be able to show, there we go, we'll be able to show a couple of things. Now, one of those things is how long did this take? All right, so let's have a look at the start. There we go, 1:40:06. And let's look at the end finish, 1:54. All right, so time taken 14 minutes, 19 seconds. Now, Azure Functions maximum running time is somewhere between 5 and 10 minutes, depending on how much you've paid for Azure Functions. They're not meant for long running tasks, they're meant for scale out tasks. So we can do a couple of things here. We can either do a durable function to bridge between the tasks, or we could set up another logic app to start the second Azure function once we've got that image in the shared image gallery. Because remember, we're outputting from here directly to the shared image gallery. That's replicating things around. All right. Now, one of the things that we did there, we talked about, was installing languages during the customization phase. If you want to do the same thing, the code is right here. So if you go to my GitHub account at Jim Moyle, install language pack, we can see that this will look up exactly which features on demand go with which language. It will grab the correct cab files from each of the 2 ISOs that you need to do so. You'll need to put these into Azure yourself because the ISOs are behind a login, rather annoyingly. But that's fine, we can do that, and we can see that as part of that installation, all of the features on demand are now there. So, we've built the image, we've customized it, and we've deployed it to the shared image gallery. We're going to start the last of our functions. We're going to do it locally this time, just so that I can show you that we can actually, if you're running Azure Functions, happily debug our Azure Functions locally. Look, we've just hit a breakpoint in our Azure Functions. We've just allowed it to go on. So if you're used to VS Code, if you're used to working with PowerShell, then you can absolutely do all of this. So that Azure function is now going away. It's going and building the host pools. And what we'll end up with is, here we go, our resource group. Now this is the ARM release, so currently public preview. That host pool is up. That Windows 10 multi-session VM is up. And that is everything ready to be logged onto with absolutely no user intervention whatsoever in the entire chain. You can find all the code I used here, which is again on my GitHub. There's not a lot of documentation. There's not a lot of comments in the code. Hopefully that will come later. Now, one of the reasons is that you may not want to use particularly the code for Azure Image Builder is that 5 hours ago, because Azure Image Builder is just about to go GA, they released their brand new Azure Image Builder PowerShell module. Now, the stuff that I've got in my GitHub account is all great, but it relies a lot on directly calling APIs and all kinds of other things. This is far simpler, and I will rewrite it to do that. So what are your next steps? Well, go and look at Image Builder. Go and look at the shared image gallery. Go and look at Azure Functions and Logic Apps. Azure Image Builder have also got a way to deploy builds using Azure DevOps and pipelines. That's super interesting, and that's something I'm getting into with a couple of customers now. It's a very exciting world out there. There's a whole lot of options. So thank you so much for coming and paying attention to me on this breakout session, and I will see you around.